All right, so today we're simplifying radicals, and this should be pretty short and pretty easy. Remember, you can pause and try these on your own and check your answer with mine afterwards. It also might be a good idea to try the quiz that's posted up above on simplifying radicals and see how you do. So let's start with the first question, the square root of 20. And looking over these, they're mostly square roots, a couple of cube roots. So the square root of 20 is typically broken down. A lot of times teachers will teach that you're going to break it down into a perfect square. So 4 and the rest. 4 times 5. 20 is equal to 4 times 5. And it shows up here at the top that we can take radicals and split them up. And then, of course, the square root of 4 is 2, and the square root of 5 remains square root of 5. So that's what we get. But another way to work through these, if you come up against some trickier problems, I'll do this in green, is to take 20 and break it down into its prime factors. So we know 20 is 4 times 5, and 4 is 2 times 2. And let's bring that 5 down as well. So if we know we're doing the square root of, if we know we're doing the square root of 2 times 2 times 5, and doubles come out, any 2 pairs come out, then that, of course, also simplifies into 2 square root of 5. The square root of 200. Well, if I break it down and I think about my perfect squares, I know that 100 is a perfect square, and 100 times 2 is 200. So breaking this down, we get 10 square root of 2. If you used a prime factorization, this would go for a while. 2 times 100. 100 is 10 times 10. And this is 5 times 2 times 5 times 2. And let's bring this 2 down. So remember, pairs come out. So there are 2 2's, so a 2 would come out. Let me put a radical around this. And there are 2 5's, so a 5 would come out. We're multiplying. And the square root of 2 remains in. So you can see the answer is the same, 10 square root of 2. Square root of 45. Now, I'm only going to do the prime factorization for the more difficult ones. Square root of 45. Square root of 9 times the square root of 5 is 3 square root of 5. Square root of 250, well, 25 goes into 250. It's a perfect square. And 25 times 10, so 5 square root of 10. X to the 7th. So, knowing that this means x times x times x, count those, 1, 2, 3, 4, 5, 6, 7. 7 x's multiplied together, and we can only take out pairs. So there's 1 coming out, here's another 1 coming out, here's another 1 coming out, and an x is left in. So what we have here is x to the 3rd power on the outside, radical x on the inside. The next example shows a 3 outside multiplying the radical. Since it's right next to it, that means multiplying. So we need to break down the 12, and look, we have x to the 7th again, just like we had here. So we already know what that's going to be. So the 12 Let me do a factor tree over here with 12, although you might already know it. It's not a tough one. 4 times 3, and 2 times 2 times 3. So there's our 2 2's. So for 12, we know that it's the square root of 4 and the square root of 3. And x to the 7th, we already simplified. I'll use my answer over there, x cubed, radical x. So now what is simplifying here? We've got 3 times 2, and we've got x to the 3rd. And then what's left under the radicals, we can multiply those back together, 3x. So 6x cubed, square root of 3x. And don't forget, we kept that 3 on the outside multiplying.
Okay, take the divisor and try to determine how many times 12 goes into 51 without going
50, a cubed, b squared. So 50, I'm going to do this all under the same radical. I'm showing you different strategies, but they're really all the same. So square root of 50, we've got 50 is 25 times 2, a cubed is AAA, and b squared is BB. So this is 5 times 5, so there's the 5 that's coming out. Or you might just know the square root of 25 is 5. I have 2 a's in there, so an a will come out. 2 b's, so a b comes out. What's left under the radical? 2 and a. Square root of 2a. So 5ab radical 2a. The next example shows a fraction. So you've probably seen this before. Let's review. We can take a fraction and split it up into its own separate radicals. So on the top we'll write the square root of 2, and on the bottom we'll write the square root of 3. Then what we have to do here, and it actually comes up in another lesson, is we have to do what's called rationalize the denominator. And we have to rationalize the denominator anytime we have a radical in there. All right. Quite simply, it's done by, in this case, multiplying the top and the bottom by that same radical. So what happens then? Well, the square root of 2 times the square root of 3, 2 times 3 under the radical is 6. And the square root of 3 times the square root of 3 is the square root of 9. But this is the same as having radical 3 times 3. And so it really just equals square root of 6 over 3. Because multiplying a radical by itself gives you that number out. All right, a couple more to go. Ooh, so now we move into cube root and a cube root. So remember, for square roots, we only needed 2 of a kind under the radical. For cubed roots now, we need 3 of the same factor. Of the same factor, or if you want, we need 3 of a kind underneath the radical. So it's going to be very beneficial now to take the number under the radical, or whatever you might have, and stretch it out. Do the prime factorization. Do the factor tree. So 4 is the same as 5 times 8. 5 is prime. 8 is the same as 4 times 2. Bring the 5 down. 4 is 2 times 2. And let's bring the 2 down. So this is the same as 40. And we have cubed root of 40. Do that in a different color. Let me pop this up. Cubed root of 40. So we need 3 of the same factor. Here they are. To bring it out. So a 2 comes out and the 5 remains underneath the cubed root. Don't forget your index, the little index of 3. All right, I see a big problem here. Let's stretch this out. We've got a 24. So on this side, let's do the prime factorization for 24. 24 is 3 times 8. 8 is 4 times 2. 2 times 2, bring down your 2, bring them all down to that level. And now we can see we definitely have a value that we can simplify. So let's write this. Cubed root of, and let's stretch this whole thing out. 24 is 3 times 2 times 2 times 2. X cubed is x, x, x. Y to the 4th is y, 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 y. Z to the 5th, I'm going to run out of room. Let me see if I can grab the factor tree and just bring it down. There we go. Z to the 5th is 5 z's multiplied together. 1, 2, 3, 4, 5. And W to the 6th. 1, 2, 3, 4, 5, 6. All right. Learn from me. Write them a little smaller. Now we can bring out 3 of a kind. You bring one of them out. So we're bringing out a 2. We're bringing out an x. Here's 3 y's. We're bringing out a single y. Here's 3 z's. Bring out a single. And I have 3 w's here. And I have 3 more w's right there. Now make sure you know what was left under your cubed root. What's left? Well, we had 3. We have a y. We have z squared. And no w's remained under the radical. So let's put this all together. 2xy z w squared cubed root. Make sure you tuck that 3 into the little crook of that arm there. Y, 3y z squared. And there is that final answer. Now I'm going to do one more with you. Let me see if I can find a tougher problem out of the book that normally you would be doing in class. And let me see here. Page 93. Get part of this work done for tomorrow. You'll be doing page 93, 3 through 45 odd. So let's see. Let's look at 35 from the book. 35 says this, square root of 300c. And then we'll also try one of these word problems that you would be doing tomorrow. Okay? So first, we're back to square roots. If nothing's written here, it's automatically a square root. See if you can simplify that.
All right, how many times is a factor of 6a? Plus 6. 6a plus
100 is a great perfect square times 3 times c. And this is 10 times 10. So a 10 comes out, and square root of 3c is left. All right. Let's also tackle number 41. 41 is a word problem, so I'll read it and I'll draw it at the same time. The length of the hypotenuse of a right triangle, picture here. The length of the hypotenuse of a right triangle is 24 meters, and the length of one leg is 12 meters. Find or express the length of the other leg in simplest radical form. So they want us to find this leg. I'll call it A. And what's our famous theorem for right triangles? The Pythagorean theorem says a leg squared plus the other leg squared equals the hypotenuse squared. So we have A squared plus 12 squared equals 24 squared. All right, let's get those squares figured out. A squared plus 144 equals 576. Subtract over 144. A squared equals 432. And we want to express A. So we would be square rooting the left and square rooting the right. Now normally I would say u square root, so u plus minus, but this is a length. And we know that length can't be negative, so it's just positive. So you need to figure out the simplified answer for the square root of 432. So the first thing you're going to do now, since you may not know what goes into 432, is a factor tree. I know that 432 is going to be 2 times 216. 216 is 2 times, we could probably put 4 in there, 108. 108. 2 is the easiest one to keep going with. 2 times 54. 54 is 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. So I have quite a big set of numbers here. But I can tell what I am going to simplify out. I have a 2 coming out. I have another 2 coming out. And I have a 3 coming out. And a 3 staying in. So 4 here times 3 is 12, square root of 3. And I could do a little check if I want. That means that 144 went into my original 432. And yes, it does. See you tomorrow.